Hello everyone, I am Dr. M. Manikam, Assistant Professor, Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So in this lecture series video, we will discuss about transistor, BJT, common emitter configuration. So in our previous video, we have discussed about bipolar junction transistor, common base configuration circuits we have discussed. In this video, we will discuss about common emitter configuration. This is the bipolar junction transistor. There are two types, NPN and PNP transistors. So already we have discussed in our previous video. So common emitter configuration. So in this common emitter configuration, so the most widely used in BJT configuration. So this is the common emitter is the widely used for different applications. So emitter terminal is common in both input and outputs. So all other two terminals are, one is input and one is output. So it provides the high current gain, voltage gain and power gain. So all are high voltage gain, current gain. So higher outputs is coming. So we can utilize for different applications. So this is a circuit diagram for common emitter configuration. So here base is the through the base the input voltage, and so through the collector that is the output voltage, you can take it is. So emitter is connected the ground or both the batteries VBE and VCE. So the emitter is the common one. This is a circuit diagram for common emitter configuration. So current through the VBE, that is the IB, this base current, then current through the collector, that is IC, and current through the emitter, this IE. So basic concepts for common emitter configuration: this is input applied in between the base and emitter. So in between base and emitter, we are supplying inputs. This is the one. So in between the base and emitter, we are supplying input voltage VBE, and then current IB is the input one. Then output taken between the collector and emitter. So we have taken collector and the collector the terminals collector and emitter. The emitter will act as the common reference point. So this is what we have kind of word, this common emitter configuration. So VB is the base emitter voltage and VCE is the collector emitter voltage. So this is the basic concepts. Base emitter junction which is already forward biased, then collector emitter junction working in the reverse biased conditions. So there are two PN junction diodes inside the transistor, NPN or PNP transistor. So one is base emitter junction is working in the forward bias, then collector emitter junction working in the reverse bias. So the current flow in the common emitter amplifier or configuration, that is particularly in NPN transistor. So base emitter junction is forward biased. Already we know that. So small base current flows due to VBE. So VBE is the potential difference between the base and emitter. That is power supply we have supplied. Then this allows a large collector current to flow. Then collector current is controlled by base current. So this is the mechanism that is followed in this inside the transistor which is connected in common emitter configuration circuits. So relation between the currents, that IE, that is equal to IB plus IC. So both the sum of base current and collector current, that is equal to emitter current. So the base current is the input current, then collector current is the output current. This is the input characteristics for common emitter configuration. So here in x-axis, that is VBE, and then y-axis, that is IB. So VCE voltage is fixed one, common one, this constant, so maintaining constant VC. Initially we are maintaining VC voltage is 0 volt, then it is working as like a PN junction diode. So it's from the 0 the value, the VBE voltage is gradually increasing, then we'll after reaching the 0.7 voltage, the cutoff voltage, I mean breakdown voltage of the particular silicon semiconducting diode material, so it is gradually suddenly increases to the highest value of base current for the constant voltage VC is equal to 0 volt. Then if you are increasing the VC voltage between voltages between collector and emitter, like 10 volt 20 volts, so it is moving or shifting right hand side, so the cutoff voltage or increase breakdown voltages are increases up to nearly 1 volt. So this is the input characteristics of common emitter configuration. Then this is the common emitter configuration for output characteristics. So in saturation region, so in output we are following the x-axis VCE, then y-axis that is IC. So we are maintaining VBE, we are maintaining so the VCE, and then VBE is a constant one. So we are for IB voltage, if we are maintaining constant, the IB is equal to 0 means, so for IB voltage, sorry, IB current, base current is 0 means the transistor working in the cutoff region. So this is the cutoff region. Then if you are increasing, so if you increasing the IB current like 20 microampere, 40 microampere, 60 microampere, like that up to 120 microampere, so the in saturation region, so it is gradually suddenly increases and reaches the saturation point. So almost in active region all the IC currents are constant for different values, but the constant value constantly maintaining throughout the while increasing the VCE current, I mean VCE voltages. So this is the output configuration or output characteristics of the common emitter configuration. So by this graph we can conclude that while increasing the IB current, so the IC also increases, because so the total current value, so IE is equal to IB plus IC. So the current gain of common emitter amplifier, that is current gain beta, we can say it is beta IC by IB. The beta is much greater than 1. So it is a value of current gain voltage. Current gain is the more than 1. So it is a good output. So we can use different applications. So typically beta value ranges from 20 to 300. So its value is gain value is very high, so we can utilize for different applications like audio amplifiers, signal amplification stages, radio and communication circuits, and also it is used as a general purpose amplifier purpose. So its gain, current gain is 20 to 300 value is there, so you can utilize the above mentioned applications. So the main gain characteristics are in common emitter configuration: high current gain, then high voltage gain, then high power gain also. So among the all other configurations like common collector, common base configuration, and compared to those two, so it is the best one. So thank you for watching this video. Thank you.